Hi, welcome to the part 18 of this video series. We are looking at important exam questions for AC 304. In this video, we will look at one more case study and some more additional questions. For questions 1 to 108, please refer parts 1 to 17 of this video series. Please subscribe to my channel and like my videos. Please drop in your comments if you have any suggestions or any constructive feedback. In this video, we will look at the Contoso case study. In the previous video, we looked at the Fabricam case study, and here we are looking at Contoso. Okay, there are primarily I see there are two case studies out of which I got both in the exam. Similar questions. In some, the questions were exactly the same, and there were one or two additional questions which I could not find in whatever I had read. I had to answer it based on my knowledge to the best of my capacity. So the way this question is structured is it gives you overview. This is a case study. It gives you overview, and then here it talks about the existing environment of the historical transaction query system. Okay, and then here it's talking about what are the requirements. And in this slide, there are requirements with respect to the payment processing system. So this is a new system, new requirements, and this is the requirement for the historical transaction query system. This slide shows requirements for the information security requirements. And that's it on the case study. In the actual exam, you will get different tabs so that it is more readable and the entire case study is more structured. But I saw exactly same case study, word by word, same case study. Now let's go to the questions. You need in this you need to recommend a compute solution for the middle tier of the payment processing system. So we are looking at the compute solution, and there are four solutions here. First of all, the payment processing system, they want a compute solution for the middle tier of the payment processing system. So if you go back to the case study and if you find this is a section which talks about requirements for the payment processing system. So what I do is I take the keyword from the question and go here and try to search for the keyword. So I got the keyword here, the requirements for the payment processing system. Now this line talks about the middle tier because in the question we had middle tier, this middle tier. So since we have middle tier in the question, I am searching for the middle tier in the case study. So the line I get here is the middle tier and the web front end must continue to operate without any additional configurations. Are there any more middle tiers? Yes, I found one more. It says that the number of compute nodes on the middle tier of the payment processing system can increase or decrease automatically based on CPU utilization. Now let's try to answer this. See, they want elasticity. Scale up, scale down should happen automatically. They want elasticity based on the CPU utilization. Now, if you try to see these options, scale sets is the virtual machine scale sets provides you this option, the option A. If you are from the AWS background, scale sets are similar to auto scaling in EC2. So here, if you see this documentation, here we see that the virtual machine skill sets, it lets you create and manage a group of load balancers, load balanced VMs. Okay, so the number of VM instances can increase automatically or decrease automatically in response to the defined schedule, or in response to the demand. Demand means in our question is talking, in the case study is talking about increase or decrease automatically based on CPU utilization. CPU utilization is telling the demand. If the CPU utilization is more, suppose you started with 2 VMs and suddenly you see when you started the CPU utilization was 20%, which is fine, and hence 2 VMs will work. Now after some time, since the load increases, CPU utilization becomes 70%. Now it will automatically scan new VMs. You see this, it's 70%, hence it created two more VMs, VM3 and VM4. So this is auto scaling. This is virtual machine auto scaling. So this is scale sets. So this option looks correct, but let's look at other options. Option B. So what is availability scale sets, or sorry, availability sets? So this is a group of VMs which is used to provide availability. So this is called availability set, so that even if one VM is down, the other VM will take care of it. So the intention here is availability. The intention is not scale up, scale down elasticity. Hence availability set is wrong. B is wrong. Now AKS. Now AKS is primarily for containerized applications where AKS offers serverless Kubernetes and integrated continuous integration and CI/CD pipeline. Here we do not have any such requirements because the middle tier, it says it has to scale up and scale down automatically. It is not microservices based middle tier. That's what it seems like. The AKS is of no use. Let's look at function app. Function app primarily it's a serverless compute. So you have something called a service called Azure function, and inside the function each function is called a function app. So in this case you do not function app will not help you scale up and scale down automatically. You can use function apps or these functions or Azure function. Why? When you should think about in which scenarios you should use this. You should use this when suppose you have event hubs, streaming jobs coming in, and you want to do some sort of immediate processing. The processing completes in 10 minutes and the application goes away. So that way it doesn't require a compute to be built every hour. Whenever you need it, it gets activated, it processes, and it completes. And if you need to call 4 functions, 5 functions, you can do that. But this is very different from what the case study is asking for. The case study is totally focused on elasticity with respect to scale up and scale down for VMs. For VMs, if that is what is needed, then scale sets is the solution. So let's lock this answer and move forward. So this question talks about a backup solution for data store of payment processing system. Let's search for payment processing system. So in this case study, this is a section where it talks about the backend tier. So I tried to search and did a reading. I could not find much. So I think this answer, we can do it in isolation as well. Now let's scan through the options. The first option says DPM. So DPM is the data protection manager, and what it does is, see, every organization they have some sort of business continuity and disaster recovery solution or some sort of strategy for that, where they can plan for planned outages and unplanned outages. These are two important things. So what does DPM do is, it is a robust backup and recovery system. Okay, so you can take backups and you can recover also in case of disaster strikes. You can recover, and what can it recover and take a backup of? It can do application aware backup, for example SQL Server, Exchange, SharePoint, file backups, system backups like backup system state or run full bare metal backups of physical computers, etc., and Hyper-V backups for Hyper-V virtual machines. And this can store, where will it store the backup data? It can store in disk, Azure, as well as on tapes. Please remember, DPM is not an Azure solution, it is a Microsoft solution, and that's why I think this solution, which this option will not be fitting this, because first is nowadays any option, or whenever you're trying to answer any question in the certification exam, if there are any options which uses some traditional ways, like in this case DPM also uses tapes for storing the backups. These are all outdated mechanisms. Everything should go to Azure storage, blob storage, etc. So hence I'm rejecting this option. Option A is wrong. Option B, Azure backup server. See, if you read this part of the question, this will help us answer it. In the current environment, it says it keeps the backups of the data in two physical locations that are 200 miles apart. Like this, two locations, the backups are there, and these two locations are 200 miles apart. Another important thing is it should be stored for up to 7 years. That's the compliance requirement probably. And even if you see here, even the middle tier logs, they want to retain for 7 years. So backup server is primarily used for backups of VMs. Here we are talking about data store backups. That means a database backup. So B is not an option for this purpose. Now option C, this is a potential solution because this is talking about a data store, and SQL database, Azure SQL is a data store. So if you see here a SQL database, you can set a long-term retention policy, LTR, to automatically retain backups. So what it does is, so the backups, they go from the database to Azure storage, maybe a blob storage, and it is kept there. And the question says, the case study says, current environment is retaining for 7 years, and that has to be continued in the new environment. Hence, this looks to be the right option. But let's also check Azure managed disks. So what does managed disk do is, managed disk is actually the storage of a VM. So if you have a VM, so the data that the VM stores goes to a managed disk. This is how it goes. And it can store up to 10 years. So we just want to store for 7 years for our case study purpose. So we will lock this answer and move forward. So this question, it says to provide a solution for the data store of the historical transaction query system. So the solution is only for the data store. So what is it asking? Sizing requirements and resiliency. So let's go through the options quickly. A table that has unlimited capacity, that has fixed capacity, or multiple tables which have unlimited capacity or fixed capacity. Okay. Now let's go to the case study and look for historical transaction query system. This is where it talks about historical transaction query system. And this section also talks about historical transaction query system, which is the existing environment. So if you see this section, it says the data in the table storage is 50 GB and not expected to increase. That means a fixed table will work. And the tables, they have frequent table scan issues. It is currently on Azure table storage, which is JSON structure, not relational structure. And that is moving to Azure Cosmos DB. So we have to minimize the frequency of table scans, and if a region fails, we have to ensure the historical transaction system remains available without administrative intervention. It should automatically work, and we should minimize the use of on-prem infrastructure. So in this case, like we saw, it has 50 GB and fixed requirement. So we'll go with fixed capacity. Now, which one, a table or multiple tables? Since it is JSON kind of structure, if you want to minimize the table scans, you should use a single table, which is a document. So my first answer would be a table that has a fixed capacity. And then let's look at resiliency. Resiliency means if a disaster strikes, your service should still be available. So what would we use for resiliency for Cosmos DB? AZs will not work, this last option AZ, because if a region fails, for example, then all the AZs inside that region will also fail. So AZ will not help you with this. That is wrong. Availability set. Primarily, you create availability set with VMs. So what you actually do is, if you have multiple VMs, you can mark those as availability sets and use it. But in this case, we are talking about Cosmos DB. So that leaves us with only one option, additional read region. So this is very vital. You see this? There are how Cosmos DB maintains availability. It replicates the data across regions, and that is first point. The second point is it keeps 4 replicas of data within the region. That may be in the AZs, but what if AZ fails? So in that case, it replicates across regions. So these are our two answers. Now let's look at this question. It's talking about uh, encryption. This is primarily a security and encryption related question. So we have to protect the content of the payment processing system. So this section has something about payment processing system uh, for the new requirements. You see this line in yellow, highlighted in yellow. This talks about encrypted columns. So what it is saying is the payment processing system must be able to use grouping and joining tables on encrypted columns. That means, an hypothetical example, you have two tables, and if you are joining them, there may be other fields also in these tables. If you're joining them on the common key, for example, just employee ID, so both are encrypted and the join should work. Now let's scan through the options. The first one, option A. So the first option, encryption with deterministic options. So what it does is, suppose you want to keep it very secured, then you use randomized encryption, because you know that way what will happen is everything will be very secured, but you will not be able to join multiple tables, because since it's randomized encryption, if there are two tables, the and you're joining on field one, uh, so what will happen is one field will be having a different sort of encryption, other field will be having other table, other field will be having a different sort of encryption. They will not match and they will not join. That's why for this section, we should use deterministic encryption. This seems to be the correct answer. So if you see this, it explains how to select a deterministic or a randomized encryption. If you see deterministic encryption, it generates the same encrypted value. So if you have two tables and one field in each are using in a foreign key, primary key, foreign key relationship, so it will generate the same encrypted key. So this one and this one will have the same encrypted key. That's why it will be easy to join. But in randomized, what happens is this one would be a different sort of encryption key and this one would be a different encryption key. So the moment you try to join, it will not join. So randomized, like you see here, encrypts data in a less predictive manner. So if you are joining, you want it to be predictable, because otherwise the join will not happen. Okay. So TDE, the TDE is used for encrypting the database at rest. So your data is residing inside the database at rest when it is not moving, not in motion. For that purpose, you use TDE. So whether it be SQL database or SQL managed instance or Synapse Analytics, it will work everywhere. Now Azure Storage Service Encryption. So suppose you have on-prem and the data is now moving to Azure. From here, you're moving to Azure. So what happens is it is automatically gets encrypted, the data, whether you want it or not. This storage service is the default encryption. It will encrypt and decrypt by default. You cannot switch it off. This is the feature provided by Azure itself. But this is used for storage primarily and not for uh, the database. If you want to join the fields and so on, it is not for the database, and that's why this option will not fit this purpose. Hence we will lock this answer option A. Okay, now I'm done with the case study questions, and these are individual questions not linked to any case studies. I repeat, this question onwards, it is not linked to the case study. So this question, it is a automation related question. If you read it carefully, you'll come to know that certain task has to be done, and hence I think it's the automation related question, because it says first thing is start and stop the service based on business hours. So this has to be automated for sure, because nobody would manually set and do that. Second is that scale out uh, hosts when required. So this also, there has to be some piece of automation. But let's scan through the options. Option A says Microsoft Intune. So Intune is a service which focuses on mobile device management. So mobile device management and mobile application management. So majorly it's not a tool used for this purpose that the question is asking for. So Intune looks wrong in this context, because the question is not asking anything about mobile management. Now, I don't know if this is a service in Azure, but my best guess suggests that this is something which is on Windows and you can use on your desktop. For you can create some automation tasks, and this is referring to that. I don't think so this will work in this context, because you are trying to start and stop the desktop session itself, and you cannot do it from inside the desktop automation task. That's why I think this would be potentially a wrong option. Azure automation, it allows you to automate your Azure management tasks and orchestrate actions. So in this question, we can use it very well. So you can have your runbook executions in automation, and that's perfect for this kind of question. the Azure automation solution will work perfectly in this case. I think C should be the right option, but before that, before concluding that, let's scan through D as well, service health. So this will inform you about the Azure services incidents and planned maintenance. So you can take action if you want to mitigate the downtimes. In this section, we do not have anything to do with planned maintenance. This is something which, based on the business hours, you need to start and stop. We are not dealing with any incidents in this case. That's why D looks to be the wrong option. We will lock this answer and move forward. I'll cover two more questions quickly. I'll not go into a lot of details because this video is becoming a bit longer. So in this question, let's scan through it. This is a question for API management. In this case, front door, this is a kind of a global load balancer, and this question doesn't require a load balancer, so front door is wrong. And proxy, what it does is it provides you secure remote access to your on-premises web applications. So from Azure, if you want to access your web applications which are on premises, you can do that through proxy. In this case, this is not a question for accessing that, hence proxy is wrong. We will lock API management and move forward. Now you're designing a solution on Azure and the network traffic. So these are the three requirements. So it should have HTTPS protocol, round robin routing, and SSL offloading. And these are all different sort of load balancers used for different purposes. So this is the application gateway question. So application gateway, what it is a a layer 7 load balancer, which means, say, it supports HTTP, HTTPS, WebSocket, etc., and it also supports SSL termination. Okay, and these are the other features. Load balancer, it is a layer 4. So Azure load balancer, this is layer 4. Application gateway is layer 7. In this case, application gateway would fit the bill. We'll log this answer. This brings us to the last part of this video series. Please subscribe to my channel and like my videos. I'll be posting some more videos related to some other Azure or AWS certification. See you in the next video series. This brings us to the part 18, and this is the last part for now. If in the next couple of months there are some new additions to the questions, I will add it to this question base. See you in the next product certification video. Thank you.